Hi guys, welcome to Colossus Mathematics class. Don't forget to subscribe, like and share this video. In today's class, we'll be looking into a topic in physics called electric charge conservation. I'm starting a new series on this channel which is teaching physics. Alright, so if you have not subscribed, do that so that you can see my videos when they are being uploaded. Alright, so today our first topic here is electric charge. So we are going to be looking at electricity in this series. So the first topic here is electric charge conservation. Now, what is electric charge? We know that charge a charge is a part of an atom. I get what I'm saying. Or we can say that the charge of an atom is determined by the what? By the subatomic particle that made it up. And a charge consists of three particles, which is what? The proton, the neutron, and the electron. The proton is the what? Is the positively charged electron. Is the positively what? Charged particle, rather. Don't call it electron. It is what? It is the positively charged particle. Are you seeing that now? So proton is positively charged. Are you seeing that now? This is the positively charged particle. And then what can we say about neutron? Neutron, from the word new. Are you seeing that now? You can say neutron is neutral. Are you seeing that now? Neutron is what? Is neutral. That means it has what? No charge. I get what I'm saying. What? This one has no what? No charge. Are you seeing that now? This, it has no what? No charge. While the proton is what? Is the positively charged particle. Then the electron. The electron is what? Is the negatively charged particle. Are you seeing that now? This is the negatively what? Charged particle. Are you seeing that now? So we know that an atom consists of three subatomic particles, which is the proton, the neutron, and the what? And the electron. Now, if you are to look at the location, now let me just draw a simple subatomic particle so that you can see what I'm talking about. So if you have something like this is just a simple one. Are you seeing? This is how an atom looks like. Are you seeing that now? So this is what it looks like. Let's change this pen so that you can get what I'm trying to say. So let's say these are the particles in the, are you seeing that now? These are like particles inside this atom. I hope you are following. All right, so these are particles. These are like the particles. So let me not put that there. Let me say here, it can be there too, it can be there. So I just want to label them for you so that you can see what I am talking about. All right, now if you look at, you see everything inside this place is what we call the neutron. We can call it neutron. Let's call the blue the neutron. Okay, let's label it this way so that you can fully understand the concept. So the blues, why am I still using red? I want it to be distinct. Are you seeing that now? I want it to be distinct. So let's call this blue. These are our what? Our neutron. Are you seeing? Neutron. Don't forget I said neutron is the what? Is neutral. It does not have any charge. Are you seeing that now? It does not have any charge. Then the proton. The proton is the what? Is the positively charged particle. So this is the proton. Are you seeing that now? This is the proton. And then what? This is the what? This is the electron. Are you seeing that now? This is the what? The electron. So this is an atom. This structure you can see here is what we call an atom. So these are particles in an atom. So what can you say about neutron? What can you say about neutron and proton? You can see when we talk about their location, you can see that what? The neutron and the proton are located inside the what? The nucleus. Are you seeing that now? They are located where? Inside the what? The nucleus of an atom, this middle, this center here, is what we call what? The nucleus of an atom. Are you seeing that now? And you can see that the proton and the neutron, they are inside the nucleus. Are you following that now? So proton is located in the what? In the nucleus. Neutron is also located in the what? In the nucleus. This is the nucleus. This is the spelling of nucleus. Are you seeing that now? So they are both located in the what? In the nucleus of what? Of an atom. Are you seeing that now? Now what else can you say about neutron? You can also say that neutron is what? Is located inside the particle, and it's what? It fills the space. You know, it does not have any particle. So it is neither positive nor negative. So it is just for what? It is just filling the spaces, and that's why you can see that I use the blue pen to show that it is filling the spaces left when the atom are being filled. Are you seeing that now? So now the next thing you need to know is the electron. You can see the electron is what? Is located outside the nucleus. You can see the electron on the edge. Are you seeing that now? You can see the neutrons here. So the neutrons are what? They are located at the what? At the outside of the nucleus. I get what I'm saying? And we call these parts, all these parts, we call them the electron cloud. Are you seeing that now? We call them what? Electron cloud. So I hope you get that. All right, now let us see another thing. What is one other thing that we can see about nucleus? Are you seeing that now? Another thing you can see about nucleus is that what? The nucleus is a combination of many other entities called the quark. The nucleus is what? Is the combination of other quantities called quarks. Are you seeing that? This is the spelling of what? Of quarks. Do you get that now? So this is what a nucleus combined to make. It is called the quarks. Are you following that now? So now we have seen that the electron is the negatively charged, neutron, it has no charge, while proton is the what? Is the positively charged. So all these are what? Are property of an atom. Now how can you abbreviate it? You can see, you can abbreviate it. You can see an atom consists of 3 particles called pen. An atom consists of 3 particles what? Called what? Pen. Are you seeing that? The P is what? The positively charged electron, positively charged particle. The E is the what? Is the negatively charged particle, while the N, it has what? No particle. So with the use of pen, you can know the properties of an atom. Are you seeing that now? Now there are some other things that we need to know about atom. You know what we said? Electron. We said electron is the negatively charged, proton is the what? Electron is negative, proton is positive. Now there is something called magnitude. Don't forget, in physics when we talk about magnitude, magnitude just means number. So both neutron and electron, both proton and electron, they have the same charge. Proton and electron have the same charge. That means they have the same magnitude. So electron, we are representing our electron as E. Electron and proton have the same charge. And what do we say? The same magnitude. Magnitude just means number. And what is the number? 1.60 times 10 raised to power minus 19 coulombs. Are you seeing that? Minus 19 coulombs. You know, electric charge is measured in what? In coulombs. Are you following that now? Electric charge is measured in what? In coulombs. So this is the magnitude. This damn, it is a constant. Are you seeing that now? It is a constant. But now when we now come to distinctiveness, how can you differentiate them? You know, we said electron is the what? Is the negatively charged. Are you seeing that? Electron is what? Is negatively charged. So that means the magnitude of electron is what? Minus, are you seeing that now? Minus 1.60 times 10 raised to the power what? Minus 19 coulombs. Are you seeing that now? Then from there, I'm sure you are intelligent. You can tell what proton will be. Since we say that proton is positively charged, so that means the proton is going to be what? Plus 1.60. Are you seeing that now? Times 10 raised to power minus 19 coulombs. You can see that they are still the same thing. You see, it is just now we are putting in the sign. I see. So whenever you want to calculate something on electron, it is having negative. When you want to do proton, it will be what? Positive, because the charge is also very important. Are you seeing that now? And we know something when it comes to atom. One other thing we need to know is the law of charge. We know that charge can neither be created nor destroyed. Are you seeing that now? I hope you are jotting. Charge can neither be what? Be created. Charge can what? Can neither, just like the law of conservation of energy, that says energy can neither be created nor what? Nor destroyed. The same thing happens here. Charge can neither, are you seeing that? You cannot create it nor what? Nor destroy it. Charge can neither be what? Can neither be created nor destroyed. I'm sure you get the definition. Can neither be created nor destroyed, but they can move. Are you seeing that now? But they can what? They can move from one object to another. Are you seeing that now? They can move from one object to another. Now, we've been talking about charge. How do we denote a charge? How do we denote a charge? A charge is denoted by what? By Q. So whenever you see Q, it means charge. Are you seeing that now? Charge is denoted by what? By Q. And what? It is measured in what? I've said that here. It is measured in what? In coulombs. This is the spelling of coulombs. Are you seeing that now? Charge is measured in what? In coulombs, and it is represented with what? With Q. Do you get that now? So that's another thing we need to know about charge. Now, how are charge quantized? How do we measure the quantity of a charge? Don't forget, we said 1 unit of a charge is 1.60 times 10 raised to power minus 19. 1 unit of a charge is 1.6 times 10 to the power minus 19. I get what I'm saying now. So when we have something like this, I want to show you something like a table. So let's say I have 1 electron. We know that 1 electron is costing 1.6, or it weighed 1.6 times 10 raised to power minus 19. And what would 2 electron now be? Are you seeing that now? 2 electron will be what? 1 multiplied by what? 2 multiplied by what? 1.60 times 10 raised to power minus 19. Now I know your question. Your question is now like, Colossus, I thought you said electron is negative, so why am I not putting negative here? Yes, it is negative, and if I still put negative, it is still the same thing. Don't forget, I told you that whenever I want to deal with electron itself, that is when I will use this negative. So if you are following my class, which I expect that you should do, so that's why you should subscribe if you have not done that, so that you can see my next video where I'll be using the signs interchangeably. All right, so this will be 2 multiplied by the initial 1.6, which will give us what? 3.20 times 10 to the power what? Minus 19 coulombs. Don't forget the units. So what will 5 electron be? 5 electron will be what? 5 multiplied by what? 1.60. Can you see that? Now it is interesting. 1.60 times 10 raised to power what? Minus 19. Are you seeing that now? And that will give us what? 8.0. 8.0 times 10 raised to the power what? Minus 19 coulombs. Are you seeing that now? So this is how we measure charge. Are you seeing that now? This is how we measure what? Charge. This is the way we measure charge. So anything you want to do, you just multiply with the initial units, the initial quantity of 1 electron. I get what I'm saying. So let's see an example. Let's say an object has a net charge. Now, okay, so just write the question because of time. So an object has a net charge of 8. So let's say the net charge is 8.0 times 10 to the power minus 19. 8.0 times 10 to the power minus 19 coulombs. Then the question is what? It has how many charge? It has how many what? How many charge? That means if the total is 8.0, then how many electron is in there? Very simple. You just have to do the primary school mathematics. How do we do in primary school? We say solution. So you want to find the number of charge. You want to find the number of charge. Don't forget, 1 electron costs 1.60 times 10 to the power what? Minus 19. I see. So 1 electron is costing what? 1.60 times 10 to the power minus 19. Then how many electron, x electron, will cost 8.0 times 10 to the power minus 19 times 10 to the power minus 19. You see here, what we just do is cross multiply this and then multiply this. I see. So that will now give us 1 multiplied by 8. That's what? 8.0 times 10 to the power minus 19 coulombs. Are you seeing that now? Then x multiplied by this, that's x into what? 1.60 times 10 to the power minus 19. Can you see what I'm doing now? Times 10 to the power minus 19. Then now, what will you do here? You know, you want to make x with a formula. You will divide both sides by what? By 1.6 times 10 to the power minus 19. Are you seeing that now? So this one to divide by what? 1.6 times 10 to the power minus 19 coulombs. Are you seeing that now? So don't forget, this is x electron. So E is here. Are you seeing that now? So E is here. I want to show you something, the reason. Alright. So you can see that C will cancel C here. Are you seeing that now? 10 to the power minus 19 will cancel 10 to the power minus 19. Everything here will also be cancelled. Are you seeing that now? So what will I have? I will have x equal to what? 8.0 over what? Over 1.6. Are you seeing that? 8.0 divided by 1.6. And if you divide 8.0 by 1.6, you are going to have 5. Are you seeing that now? So 5 electron. And you can see that when we do 5 multiplied by 1 electron, what did we get? Just like this, we got what? 8.0. Can you see that now? You can see that is how you do it. Are you get what I'm saying? So that is how you do it. So now let's see another example. Let's say an object contains 10 electron. What is the total charge? What is the what? What is the net charge? What is the net charge? What is the net charge? Are you seeing that? You can see that here they are asking you for the net charge. That means what is the total? What will you do? Just do 10 multiplied by what? Electron. And that's 10 multiplied by what? 1.60 times 10 to the power what? Minus 19. And that gives us what? 10. That gives us 10.6. Are you seeing that now? That gives us, no, 10 multiplied by this, that gives us 16. 16 times 10 raised to the power minus 19 coulombs. Are you seeing that now? But I cannot leave it like this. Are you seeing that now? I cannot leave it like this. So I'll now apply standard form. Decimal is here, so I'll move it here. So that will now be 1.6 times 10 to the power 1. Are you seeing that now? Then multiply by what? 10 raised to the power minus 19 coulombs. So that will now become what? 1.6 times 10 raised to the power what? 1 minus 19, you know, indices. So that now give us what? 1.6 times 10 raised to power minus 18 coulombs. So that means 10 electron is equal to what? 1.6 times 10 raised to power minus 18 coulombs. Are you seeing that now? So that is how you do that. All right, so don't forget, in today's class we started by looking into what? Electric charge conservation, and we said that what the atom consists of 3 particles, which we denoted as what? As pen. P is for what? The proton. E is for what? The electron. And the N is for what? The neutron. All right, and then we said the nucleus contains the neutron and the proton, and the nucleus is a combination of other entity, which we call what? The quark. Are you seeing that now? The neutron and the proton is located in the what? In the nucleus of an atom, while the electron is located at the what? At outside the nucleus, which we call the what? The electron cloud. All right, and then we looked into the charge quantity. A charge is weighing 1.60 times 10 to the power minus 19. So if it is electron, that's negative, proton positive. And we also said that charge can neither be created nor destroyed, but can be moved from one object to another. We also said charge is denoted by what? By Q. Some can use capital Q. It is still the same thing. I get what I'm saying. Some can use capital Q, and we say charge is measured in what? In coulombs. And then we looked at example. We say 1 electron is what? 1.6. So 2 will be what? 2 times 1.6. 3 will be 3 times 1.6, and you go on and on like that. All right, so we looked at example, and I'm sure the example is clear to you. All right, so this is the last example we looked into. Then before we go, let me give you an assignment. So the number one, you give me your answer in the comment section. Give me your answer in the comment section. Let's say an object has a net charge. When they say net charge, it means total. Are you seeing that now? Has a net charge, and whenever you see net charge, then what you are looking for next is maybe the number of electron. I get what I'm saying now. So an object has a net charge of what? Of 40 times 10 to the power minus 19 coulombs. Find the number of charge. Find the what? The number of charge. So you get that now. So you find the number of charge here, and also confirm that when you get the number of charge, then multiply it, you should get your 40 back. Do you understand? Just like this. If you look at this one now, you can see that when I got 5 electrons, I say 5 times 1.6, it will still give me the 8.0 back. I get what I'm saying. So that is what I'm saying that you should also do. That will help you to be sure of your answer. All right, number 2, find the net charge of an object that has 30 electrons. Find the net charge if the charge contains 30 electrons. All right, so thank you very much for watching. Don't forget to subscribe, like, and share this video, and you can see how clean the class is. So imagine we have a one-on-one section. So if you need a one-on-one section, just click on the link in the bio and you can get directly to me. All right, so thank you very much, and I will see you in the next video. All right.